Okay, question 4. Which of the following statements best describes a Michaelis-Menton constant Km? So we drew out this little chart, the one that we see in our lecture slides and everything. We have the reaction rate on the y-axis, solute concentration on the x-axis. And so looking at this chart, we see that Km is found by finding half of Vmax, so here's Vmax, go half Vmax, and then find at which point this intersection occurs and travel down. So Km would be, by definition, numerically equal to the substrate concentration required to reach half maximal velocity for an enzyme-catalyzed reaction. So let's look at the options that we have on the board. Letter A, it says it is a measure of enzyme efficiency. Now, Km itself is not measuring enzyme efficiency. Like we said, it's equal to substrate concentration. You know, we're looking at a concentration of substrate, and it has nothing to do directly with the enzyme efficiency. So we can cross that one out. B, it is a measure of rate of catalytic process. So we saw from the chart, there is on the y-axis the rate of reaction, right? But Km is not the measure of rate of catalytic process. So we can scratch that one out. Now C, it has units of concentration. Km does have units of concentration. It's concentration of substrate, but it's not what Km stands for. It's units is not what it stands for. So we look at D. D, it is numerically equal to the affinity between enzyme and its substrate. D is a great answer, but it's not the best answer. So D is a correlation. The actual equation, when we look at the Michaelis-Menton equation, it does not say that, it's just a higher affinity, the less substrate there. It's just a correlation we make off of this chart. So then the last answer remaining is E, which, as we said earlier, it is numerically equal to the substrate concentration required to reach half maximal velocity for an enzyme-catalyzed reaction. So as we see, this is the exact definition of what Km is. D is a really great answer, but it's not the best answer because Km this is the actual definition. D would be a correlation made out of the chart that we see.